So let's talk some HANA technology. And yes, every once in a while we have to talk technology. We can't be all about PowerPoint and traffic lights and things of this sort all the time. Hasso has this amazing set of icons with regard to HANA that he uses. I'll go over some of those. The basic thing to know about HANA is that the combination of multi-core parallelism, data locality in memory, and columnar structures, plus the fact that we rethought everything and work together with customers to do this, and especially thanks to Colgate, who gave us the very first actual ERP system of theirs to run, that we could work with while we were building HANA. That is basically the secret for how HANA came about. The power that HANA derives is from the fact that it runs massively parallel. We have the ability in HANA, because we redesigned everything from scratch, all operators are parallel. So every operator in HANA operates in parallel. We have the ability to, if you take a modern server, it has up to 80 CPU cores, 2 terabytes of DRAM, and you can put maybe 5 or even more terabytes of SSD as the persistence on the server, and that is pretty amazing amount of computing power. The 80 CPU cores, HANA enables us to fully utilize all of them. It's unlike the assumptions of the past where people used to try to keep CPU consumption low and so forth. Here our assumption is, our belief is that the more you burn the CPUs, the faster you get the results, the less you have to store, the more you calculate on the fly, and so on. I mean, you have on a single box about that high, you get 80 CPU cores, and this is 80 CPUs, roughly 3 gigahertz clock speed on every single one of them. This is 240 gigahertz of clock speed available to you. It's unbelievable amount of computing capacity, and you have 2 terabytes of data in DRAM. So everything in HANA was designed to take maximum advantage of these two things. One of the most important statistics to remember is that HANA does, on the Ivy Bridge processor, 3.5 billion scans per second per core. 3.5 billion integer scans per second per core. This means that, and it basically scales nearly unlimited with the number of cores, the number of CPUs, the number of servers. So basically what this means is that if you have 350, if you have something, some budget forecast to run, or some manufacturing run to plan, or some sales analytics to run, or if you have to run any kind of a thing, calculate a risk for a bank, or figure out the optimal path to ship a container from Shanghai to Seattle, anything of that sort. If it requires, let's say 350 billion scans, you can do this in 100 seconds on one core, or more or less in 1 second on 100 cores. This is basically where the power is derived from. We also do, in addition to these scans, because of the native parallelism in the operators, we do about 12.5 to 15 million aggregations per second per core. And this means that we can basically aggregate anything on the fly that we can imagine, anything that we can think of. So the core of HANA is built around these principles of parallelism in the operators. All the major operators in calculations, in joins, in scans, all use parallelism. In fact, they use what we call intra-operator parallelism. Yeah, that is, in a cocktail party, you can throw that word around, that Vishal said intra-operator parallelism. What that means is basically that not only do we take a little job and distribute that across processors, we can even take, within the operator itself, we can take a part of the job and then run that also within an operator in parallel. So it's quite extraordinary. Actually, the intra-operator parallelism runs something like 6.5 times faster than just parallelism itself. And of course, today's relational databases or yesterday's relational databases don't even have native parallelism. So this is where some of the tremendous advantage of HANA comes from. So that is number one, is the parallel operators. The let me see, where is the, there is this, Sanjay has this funky icon that sort of looks like that, and with a little window like thing in the middle, and then little things like that. I think he was trying to depict a CPU like that. And that is sort of the icon when you look at Hasso's notes and stuff. That is the icon for parallelism. So that is number one.